You know that old saying, if you're not paying for it, you're the product? Well, one AI company is trying to flip that on its head. Today, we're going to dig into why Anthropic decided to keep their AI assistant, Claude, totally ad-free. It's a pretty big deal, and it really makes you question the whole internet business model. So, why they do it? Let's kick things off with this really powerful statement from Anthropic themselves. I mean, this isn't just some fluffy mission statement, right? This is like their foundational rule. It really sets the stage for everything else, showing that their whole philosophy is built around one thing: user trust. Okay, so why is this whole ad-free thing such a big deal? Well, it really boils down to a huge difference between how we talk to an AI versus how we use, say, a search engine. On the surface, they might seem kind of similar, but trust me, how we actually use them, totally different worlds. Think about it. When you go to a search engine, you're on a mission, right? You type in some keywords, you scroll through a bunch of links, and you grab what you need. It's transactional. But chatting with an AI like Claude, that's a whole different ballgame. It's a conversation. It's personal. It's open-ended. A lot of the time, you're just thinking out loud and building on ideas together. And it's not just a theory. Anthropic's data actually shows this is happening. People aren't just asking for quick facts. No, they're confiding in Claude with really sensitive stuff. They're working through super complex coding problems, and they're using it as a genuine partner for deep work. It's way less like a search bar and way more like a trusted advisor you can bounce ideas off of. Okay, so if we're having these deep, personal, complex conversations, what happens when you throw ads into that mix? This gets us to what Anthropic calls the incentive problem. And it really makes you stop and ask a huge question: who is this AI actually working for? Let's walk through a super clear example of this potential conflict. Imagine you can't sleep. You're tossing and turning, so you open up your AI to get some advice. You're probably feeling pretty vulnerable, right? So what that AI says next is really, really important. So an AI without ads, its only job is to help you. It's going to ask about your stress levels, your room temperature, your habits. But an AI with ads, it has a second job: to make a sale. Suddenly, it might be pushing a fancy new mattress or a meditation app. Now, those things might help, but the AI's goals and your goals, they're not always going to be the same. And this is the absolute key. It's all about trust. If the model is ad-free, you never have to wonder, is this genuine advice or is it just a sneaky sales pitch? That little bit of doubt, that second guessing, it can completely poison the relationship you have with a tool that's supposed to be helpful. Anthropic even says that sticking ads on the side of the chat would mess things up, because suddenly the goal isn't just to give you a useful answer anymore. The goal becomes keeping you on the page, keeping you engaged, so you see more ads. But think about it. Sometimes the best answer is the shortest one. The incentives just don't line up.
Okay, so if they're not using ads, how in the world does a company like Anthropic actually make money? Let's take a look at their business model. And honestly, the answer is surprisingly straightforward.
It's pretty simple, actually. Businesses and individual users who get a lot of value out of Claude, they pay for it. That's it. This creates this really clean, direct relationship. The company's only incentive is to make the product better for you, the person paying for it, not to sell your eyeballs to the highest bidder.
Now hold on. Being ad-free doesn't mean Claude can't help you buy stuff. It absolutely can. The really important difference is who's in charge of that conversation. So let's break down what they mean by commerce on your terms.
The main idea here is that you, the user, are always in the driver's seat. You ask Claude to find you some running shoes. You ask it to compare mortgages. And when you do, it works for you. Period. There's no outside company whispering in its ear, no hidden agenda. And that really sums up the whole philosophy, right? If the user starts the conversation, the AI works for the user. If an advertiser starts it, the AI is working for someone else. By sticking to that one simple rule, Claude's only job is to give you the most helpful answer it possibly can. So all of this, the ad-free model, the user-first principle, it all builds toward this really powerful vision for what Claude is supposed to be. And it's not just another app on your phone. They see it as a totally different kind of tool. To really get what they're going for, just think about the best physical tools you've ever used. You know, like a really well-crafted pen that just feels right in your hand, or a perfectly balanced hammer. They do one thing, and they do it beautifully. Or what about the feeling of opening a brand new notebook? That clean, fresh page. It's just a blank canvas for your ideas with absolutely zero distractions. Same with a clean chalkboard or a whiteboard, right? It's a space that is designed purely for thinking, for wrestling with a tough problem, sketching out ideas, and just figuring things out. So, what do all these amazing essential tools have in common? Yep, not a single ad in sight. By their very nature, they are free from any commercial noise. Their only job is to help you think more clearly. And that's it. That is the simple and honestly kind of elegant vision for Claude. They want it to be a true tool for thought, something as focused and as trustworthy as that blank page or that perfect instrument. So, as AI gets more and more tangled up in our daily lives, it leaves us with a really important question to think about. What does a truly helpful tool actually look like to you? And maybe more importantly, what are you willing to give up to get it?
All right, today we're talking about a brand new AI model from NVIDIA that's a total game changer for one of the most annoying problems out there, finding that one specific thing buried in a mountain of complex documents. It's called Nemotron-CoLEmbed V2, and trust me, it's a huge leap forward.
So here's how we're going to tackle this. First, we'll look at why search is so much harder now. Then, we'll get into the big trade-off that has defined AI search for years. After that, we'll pop the hood on this new co-embed model. And then, the fun part, we'll see how it absolutely crushed the competition. And finally, we'll talk about what this all means for you.
Okay, let's dive right in. The whole idea of search has gotten way more complicated. We're not just looking through simple text files anymore. The digital world has evolved, and search has been struggling to keep up.
I mean, you know the feeling, right? It's an absolute nightmare. These days, our documents are a jumble of text, tables, charts, and images. Your standard search tool, it sees the words, but it's completely blind to everything else. It just doesn't get the full picture.
And this is exactly the challenge that the entire AI industry is trying to solve. There's a name for it: multimodal retrieval. Basically, it's the quest to build a search system that understands everything: the text, the images, the tables, all at once, so you can find what you're looking for no matter where it's hiding.
Now, to really appreciate what NVIDIA has built, you've got to understand this fundamental dilemma at the heart of AI search. For years, it's all boiled down to a huge trade-off between two completely different ways of doing things. On one hand, you've got the old way, the single vector approach. It's super fast and doesn't take up much space because it crams a whole document into one single summary. But, and this is a big but, you lose so much of the fine-grained detail. On the other hand, you have the multi-vector approach. This way is incredibly accurate because it breaks the document into tons of tiny pieces, capturing all the nuance. The catch? It's always been way slower and a total storage hog. So for the longest time, the choice has been simple. Do you want it fast or do you want it right?
This analogy just nails it. A one-sentence summary gives.
We all want AI that's super powerful, right? But here's the catch. What if all that power makes it incredibly slow and expensive? Well, today, we're going to dive into a really cool technique that promises to give us the best of both worlds. We're talking smarter, leaner, and way faster AI. You know, this is probably the central question in AI right now. Is bigger always better? I mean, we see these absolutely massive models doing unbelievable things, but it makes you wonder, is the only path forward just to keep piling on more layers, more parameters? Or, just maybe, is there a smarter way to go about it? And this right here really lays out the problem perfectly. It's a classic trade-off. On the one hand, you've got all the power you could want, higher accuracy, more capabilities. But on the other side of the coin, the cost. These things get slower, they get bigger, and they get way more expensive. And that trade-off, well, it's a huge roadblock when you're trying to actually use this stuff in the real world. So that brings us to what feels like an impossible choice. How do you shrink a model down without making it, well, dumber? This is a fundamental challenge in machine learning. On the surface, it sounds simple, right? Just make it smaller. But trust me, underneath, it's incredibly complex. That challenge has a name. It's called subset selection. Okay, think of it like this. Imagine you're building the most efficient race car ever. You're standing in a massive warehouse with millions of parts. Subset selection is your job. You have to pick the absolute best, most essential combination of parts and leave all the extra heavy, useless junk behind. It's all about finding that perfect, lean recipe for peak performance. Now, here's where it gets really tricky. This problem is what's known as NP-hard. And in computer science, that's a huge deal. It basically means that trying to find the perfect answer by checking every single possible combination is,
Well, it's pretty much impossible to do in any reasonable amount of time. The number of possibilities just explodes. It's astronomical. So, okay, if you can't just brute force your way through an impossible problem, what do? You get smarter. You need a better strategy. And that, my friends, is where our hero of the day enters the picture, a technique called sequential attention. It's a really elegant and clever solution to the seemingly impossible choice.
Let's break this down with a sports analogy, because it makes perfect sense. The old way, the one-shot method, is like drafting your entire team at once, just based on their individual stats. You might end up with 5 amazing quarterbacks, but no one to block for them. It's a disaster. Now, sequential attention? That's the smart coach. It picks one superstar player, and then it reevaluates every other player to see who best complements the person already on the team. It's all about synergy. So how does it actually do this? Let's walk through the steps. First, it picks the single most important feature, the one with the highest individual score. Easy enough. But then, and this is the magic right here, it reevaluates all the other features based on that first pick. It's literally scoring them on how much new value they bring to the table. It's looking for something that doesn't just repeat what the first one already did. Then it picks the one that adds the most new information. And it just keeps repeating that process, one by one, intelligently building out this perfect little team of features. So what you get out of this is pretty incredible. We're talking 3 huge benefits. First, it's efficient and accurate. You get fast results without sacrificing performance, which is awesome. Second, it's interpretable. You can actually see why the model is making its choices. You see the order of importance it figures out. And third, it's scalable. This thing can handle the millions, even billions of features you find in today's massive AI models. It's a total game changer.
Okay, so that's the theory, which sounds great, but how does it actually stack up in the real world? Let's take a look at where sequential attention is already making a real impact.
All right, application number 1 is exactly where we started, smarter feature selection. This is all about picking the most important input data for your model. And this applies to so many fields, whether you're talking about medical imaging, figuring out what someone's doing from sensor data, or even analyzing proteins. And the results? They're pretty stunning. I mean, the researchers found it drastically improved efficiency. And what that really means is, instead of having to do a bunch of expensive, time-consuming retraining cycles, this method can find the best features in just one pass. That is a massive, massive leap forward in speed. But it doesn't stop there. The second application is honestly even more ambitious. It's called model pruning. Now, we're not just picking the best inputs anymore. We're talking about taking an existing neural network and literally removing entire chunks of it, entire blocks, to make the whole thing smaller and faster. It's a pretty wild idea. And guess what? It works. A version of this called Sequential Attention ++ showed significant gains in model compression and efficiency without sacrificing accuracy. And folks, that is the holy grail of AI optimization. You're making the model leaner, you're making it faster for all the fancy hardware like GPUs, and you're doing it without losing its smarts. That's the dream. And believe me, these 2 applications are really just the tip of the iceberg. The success of this technique is blowing the doors open on a whole new frontier for efficient AI. We're heading towards a future where making our models better is way smarter, way faster, and much more automatic.
Just look at all the potential here. We're talking about some seriously far-reaching stuff. Think about making those huge large language models, the ones everyone's talking about, more accessible to everyone, or speeding up crucial work in drug discovery and genomics. Even building smarter recommender systems, like the ones that suggest movies or products. In all of these areas, being more efficient isn't just nice, it's absolutely critical.
You see, the ultimate goal here isn't just about shrinking models. It's bigger than that. It's about making sure that as AI gets more and more powerful, it doesn't just become a tool for a select few with giant supercomputers. It's about keeping it accessible to everyone. It's about finding that perfect balance between power and accessibility. It's about democratizing AI. So, I want to leave you with this question. For a second, just forget all the technical jargon we've talked about. Just imagine the possibilities. What if, tomorrow, the most powerful AI models in the world were suddenly 10 times smaller, 10 times faster, and 10 times cheaper to run? What problem would you solve? What incredible idea could you finally bring to life? Because that is the future this kind of work is building. All right, welcome to The Explainer. Today, we're going to break down a research paper that just might have cracked one of the biggest problems in AI video generation. I mean, we've all seen these incredible AI-generated clips, right? They can create these stunning worlds. Some look totally real, others are like a painting, and some are just completely out there. The creativity, the detail, it's just mind-blowing. But have you ever noticed that? They're always so short. Just when you're getting into it, poof, it's over. So why is that? Well, it's not because the AI runs out of ideas. The reason is actually way more technical and kind of fascinating. So let's get into it. The big problem here isn't about creativity. It's a hard physical limit, a hardware problem that's basically kept AI video stuck in these tiny few-second loops. If we ever want to get from seconds to minutes of video, we have to solve this huge memory problem. Okay, think about it like this. For a video to make any sense, it has to be consistent, right? A character needs to look like the same person from frame to frame. To do that, the AI has to constantly remember what it just created. It's looking at the past frames to figure out what the next one should look like. And this is where we hit the wall. Because that memory, it fills up, and it fills up insanely fast. This is the big bad, the villain of our story today. It's a system-breaking issue that has held back AI video for years. All right, section 2, let's meet this memory hog. Now, it has a fancy technical name, but let's just call it the AI's short-term memory for now. This right here, this is the bottleneck. The official term is the KV cache. The best way to think of it is like a scratch pad. As the AI generates a video, it's constantly jotting down notes about what's happening, the characters, the background, everything. And of course, the longer the video gets, the more notes it has to write down. Now here's the crazy part. The AI model itself, the brain of the operation, that's a fixed size. It doesn't change. But this KV cache, this scratch pad, it just keeps growing with every single frame. It balloons in size until it's just completely out of control. Just how big are we talking? Get this. To generate just 5 seconds of a pretty standard video, you can need 34 gigabytes of memory just for this cache. That's huge. In a lot of cases, that's more memory than the entire AI model itself. And that's the bottom line. It's more memory than a top-of-the-line consumer graphics card, like an RTX 4090, even has. The system literally just runs out of space. The GPU throws its hands up, and the whole thing crashes. This has been the brick wall for AI video creators. And look, this isn't just some nerdy efficiency problem. It's a creativity problem. When the memory is this limited, the AI starts to forget things. A character's shirt might change color. Objects can just vanish. The whole scene falls apart. You can't tell a coherent story if your narrator has amnesia. So, how do you get past that brick wall? Well, this is where it gets really clever. The researchers behind this paper found an insight, a kind of secret weakness that's hiding in plain sight in every single video. And what's that secret? Massive redundancy. Think about it. In any video, a huge amount of the information is just repeated. That blue sky, it's the same blue for hundreds of frames. The background behind a talking head, it doesn't change. So the AI is wasting a ton of memory, basically writing down sky is blue, sky is blue, sky is still blue, over and over again. And that was the big aha moment. What if the AI didn't have to write down everything? What if instead it could come up with a really efficient shorthand? Okay, so this brings us to the actual solution. It's a clever compression trick called Quant VideoGen, or QVG for short, and its entire job is to tackle that memory hogging KV cache. The plan is actually pretty simple, but it's super powerful. QVG has a 2-step plan. First, it looks at all the data and groups together all the similar repetitive stuff. Then, and this is the key, it only bothers to remember the differences, the small changes from one frame to the next. Okay, take a look at this. This is what the raw data in that KV cache looks like. It's a mess, right? All noisy and scattered. This is the inefficient version that's eating up all our memory. And now, look at this. This is the data after QVG works its magic. See how it's all smoothed out and organized? It's taken all that redundant noise and simplified it, leaving just a clean, compact signal. I mean, the difference is just night and day. But it doesn't stop there. There's a second step that makes this shorthand even more precise. Think of it like this. It takes a couple more passes at the data, each time getting a little more detailed, making sure that no important stuff gets lost during the compression. So, the big question, does all this smart compression stuff actually work? Let me tell you, the results are
Well, they're not just a little better, they're a total game changer. Okay, so remember that insane 34 gigabyte memory footprint for just a 5-second video? With QVG, that gets slashed down to just 5 gigabytes. That's a reduction of almost 7 times. It's a huge deal. And here's the kicker, it's not just about saving space. Look at these numbers. QVG saves a little more memory than the old way, sure, but check out the quality score. It's way higher. So how is that possible? How do you use less memory and get a better video? Well, by getting rid of all that redundant noise, the AI can focus its brainpower on the details that actually matter. It's the definition of a win-win. So, what does this actually mean for people? It's huge. The researchers point out that for the first time, you can run a powerful video model on a single RTX 4090. This takes long video generation out of the hands of giant tech companies with massive data centers and puts it right onto the desktops of creators everywhere. It's a massive leap for accessibility. So when memory isn't the roadblock anymore, what happens next? What kinds of worlds are we going to create? We're talking about unlocking the potential for everything from minute-long animated shorts to fully interactive, endlessly generating worlds. That barrier, the one that kept AI videos stuck in those tiny little loops, it's finally been broken.